Hello and welcome everyone to this new video in our series about OpenGl ES for Android using Java. In this video, we will load a Wavefront file. These Wavefront files can be opened in a text editor, as you can see here, since it includes only text and the text has a certain format. You can find a lot of information about it in this Wikipedia link. However, for this tutorial, I will not be going through the whole possible formats for these files, but rather than that, I will be exporting these Wavefront files, which have an extension of OBJ using Blender, and then looking at those files and handling the lines which we need to load a mesh with some vertices and normals and texture. So this file here summarizes some of these features. You can see that any line which starts with a hash, this is a comment line, so we'll ignore it. Then you have material lib here. I will also ignore such lines. Then we have the object name. We start with O. I will ignore these lines. Then we have lines starting by V. These are vertices, and as you can see, we have 3 coordinates. So X, Y, and Z. We could have multiple vertices. So then we have normals, which start by Vn, and each normal has also 3 coordinates representing the vector direction. Then we have texture, and each texture will have 2 coordinates. Then we have a smoothing here, S. I will be ignoring that. Again, some material definitions. I will ignore it for this tutorial. Then we have the faces, and each face, as you can see, start by the letter F. Then we have 3 parts, so 1, 2, and 3. And each one of these parts represent a vertex. To draw a triangle, we need 3 vertices. This is the data of these 3 vertices, and this data is arranged, as you can see here, as follows. So the first number would be the vertex index. So here index 11. So the indices of these vertices, now here we have only, for example, 3. So this index is 1, 2, 3, and so on. There were like more vertices, however, I delete them, as you can see here. The second number here is the index of the texture. So 1 means this first texture point here. And then we have the normal, and for that we have the index 1, and as you can see, this would be this normal here, and so on. So in this tutorial, we will write a simple Wavefront reader which will read an OBJ file and then read all these informations and then construct an object from that. Our object from the current tutorials, which is called PCT, which stands for Position Color Texture Object. We will modify it and we will make it Position Color Texture Normal Object. And then this new object will be able to take the normal information and use it. So let's start by opening our model in Blender and exporting it. So when Blender starts, it shows you this default scene where it has a cube. What we want to do now is to go to File and open our model. So I have this model here called cube-like inside our project file. I will open it. Here I have a simple mesh. So I just take the cube and added triangle-like front to it and added a texture, as you can see here. So let's export this file. So we go to File, Export, and then we choose the Wavefront, the .obj. So as you can see here, I already have the file because it has been exported before. So let me call it now here obj2. And here on the right, we have the export options. So you can see that we are exporting the geometry. You can check that we want also to export normals, colors, and anything else you want to include. There is an important option here which is called triangulated mesh. If we did not check it and we export it, and let me show you the exported file now. So this is the exported file as we show in the introduction. It has some header here, then the vertices, normals, texture. However, here on the faces, you can see that we have 1, 2, 3, and 4 vertices. So the faces are exported as they are defined here. So we started from this rectangle where the faces had 4 vertices, and this is how Blender exported this file. However, in our Java code, we want triangles. So now we go to export Wavefront, and then we will make sure to click this option here and then export. And now you can see that we have 3 vertices. So each face is a triangle. And now we have our front wave file, the .obj file. Let's go to the Android Studio and load it. So this is our project from the previous tutorial. Let me close it and let's go to the GL directory here and let's add a new Java class and call it Wavefront loader. So I already prepared the code of this file. Let me paste it here and we will go through it line by line. As you can see here on the top, I defined it two static classes. This means that these classes are independent from the class Wavefront loader which contain them. The first class called vertData. This class simply includes three integers. These integers will hold the indices of the vertex, texture, and normal, and will be used when we read the faces from our Wavefront file. Then we have the class face, and each face will contain an array of vertex data, and this array will be of size 3 as you can see here. So in the constructor we already initialize it to 3 vertices, and in this special constructor here we are passing an array of integer. This array will contain numbers which are read from the text file with the obj extension. And what will happen in this constructor after constructing this vert data array, we will go through the input from 0 to 8, from index 0 to index 8, and we will assign it to the first vertex, second, and then to the third one. Very straightforward, I will say. And then here we start our Wavefront loader. As you can see, we have a string name for the file name, context. We will need it since we will be reading resources. And then we have three lists. The first list will hold the vertices represented as a float array. So here we will have three floats only. Then we have the texture coordinates. So also here it's a list of float array. However, here we will have only two floats in each list. And then we will have the normals. Again, we will have a list of float array with three floats in it, in each entry. And then we will have the list of the faces. Basically what we will do, we will go through this file, and first we will fill the list of vertices, then the list of normals, and then the list of texture, and finally the list of faces. And you can see here the constructor of the Wavefront loader. It requires the context and the file name, so it saved them inside the corresponding member variables, and then we initialize our lists and we call the function load. So in the function load, the read and parsing of the file will be achieved. So let's go to the function load. So this was a debugging variable. I don't need it anymore. So in the function load, first thing we use our util function read asset file to read our obj file, and then we check if it's null or empty. So let's go to the util file and add this function null or empty. So it's a simple util function which take a string and it looks if the string is null, then it return true, or if it's empty, then also return a true, else it return false. So if our string is null or empty, we throw an exception, else we start splitting the file. So for splitting, we use this regular expression here where we are splitting on the carriage return or new line, and then we will get a list of strings. Each one of these strings represents a line in our obj file. So we loop over these lines and we parse them one by one. So for each line, we check it also if it's null or empty. So let me use the util function. Then we remove the white spaces from the line, from the end and starting of the line. Then again, we look if it's empty. If not, we go to the next step where we check if it starts with a hash or this mtl-lib or use mtl o or s, all the tags basically which we will not be handling in this tutorial. So if the line in one of these cases, we ignore it. Else we check if it starts with vn, then that would be a normal. If it starts with a vt, then it would be a texture. And if it starts with v, it would be a vertex. For the normals, we call this function getFloats after throwing this vn. So we are replacing the vn with empty string. So basically we are only passing the numbers. Then this function getFloat should return three floats for us. And this float array, which contains three floats, will be added as a normal. Then we go to the next line. If it's a texture, then we call the same function getFloats. However, we are expecting only two floats here. And then again, take the returned float array and we add it as a texture. Then we return. If it's a vertex, then we expect three floating numbers. So we again call this function getFloats and we add the returned float array as a vertex. So let us check now this function getFloat. This function is very simple. It takes a string which we want to parse and then the number of floats which we are expecting inside this string. And as you can see, the first step is to trim this string, so through the white spaces from the beginning and end of the string, then split it using white spaces. Then we will get an array of strings. So we are doing that because, as you can see here, all our numbers are separated by white spaces. So here, actually, it's only one space. However, the circular expression is more generic. So after this split, we will get our numbers as a list of strings. Then we create our return array. It should also contain n floats, the number which we are expecting, and then we loop over the splitted strings. So this variable here is, and for each string, we first check if it's null or empty. We don't do anything. If not, then again we trim, which I assume here maybe not necessary since we already split it using the white spaces. However, I will keep it. Then again check if it's empty or null. So if we passed all these checks, then we use float.parseFloat and we pass the string. So this function should return the corresponding floating point number. We assign this number to our current return entry and we increase the index. And then we continue over the loop and finally return the result. So that's it for parsing the normals, texture, and vertices. What's left is parsing the faces. For passing the faces, we call this function getInt, which is similar to the previous one. So we pass the string after removing the f from the beginning. This function doesn't take the expected number of integers as a parameter since we assume that we will always have 9 integers, and this function will return the integer array, and we will pass this array to this face class where the indices are stored, and then we append the new face to the faces list. That's it basically for this function. What's left is only to look into this getInt function. So as we did in the getFloats, we split the string. So we split the input string using this white spaces regular expression, and then we create the return array, and then we loop over the result of the split, and every time, as we did before, we check if it's null, and then we trim it and then check again if it's null. And if all this has been passed, then we do another split. However, here we split using the forward slash. So remember that in these phases here, first split is over the white spaces, so it will give us an array which include 1, 2, and 3 strings. And the second split will be over each one of these strings. So we are splitting over this slash, and then we will get our integers. So as you can see here, we are expecting 3 integers. So each time we look at which index we should add this new parsed integer, we first put there -1 in case the parsing went wrong. And then we again check here for null and trimming, so on. And if all these checks are okay, then we call the function parseInt, which take the strings as an input and return for us the integer. And as you can see, we check this integer if it's smaller or equal to null. So the indices should start by 1. So if the index is smaller or equal to 0, we throw an exception. Other than that, we add the parsed integer -1 because here in Java, our indices start from 0. And that's it basically. So now we have finished parsing and loading this whole obj file. I also added here some helper function to this obj file, as you can see. So the first helper function called has texture, and it checks if our texture list is empty or not. The same here for has normal. Then there is this function get faces, and it takes as an input 2 booleans, texture and normal. This function will take our parsed file, so the arrays that we already filled from the file, and using them it will build a float array, and this float array will contain the data as we expected it in our object. So basically in this PCTObject. And in this PCTObject, later we will make a new change so that the normal data will also be saved and handled inside this object. So if you remember from the previous tutorials, this PCTObject class expect the vertex data to be an array of float which is ordered vertex by vertex. So for each vertex, we start by the position, then colors if we have colors, then texture, and today we will add for that normal. So this function will take the parsed file and arrange it so that we can use it in this object later. The first thing in this class is to compute the stride, and the stride will be the number of floats per positions, since we always need positions in our vertices. Then if we want a texture, we will add the floats per texture, and then if we have a normal, then we will add also the normal per texture. Let me add the definition of this variable, and that would be 3. And now we know the size of the float array which we will return, and this would be the length of our stride multiplied by the number of faces which we have, and by 3, since each face has 3 vertices. Then we define this variable current vert, which tracks the current vertex in the return float array which we want to fill. Then as you can see here, we have two nested loops here. The first loop is over the faces, then this loop starting from 0 to 3. This is over the vertices in each face. Then we can here get a vertex. The vertex will be taken from the current face with the vertex data from the current index, which correspond to the variable I. And then as you can see here, first we start by vert index, which contain the index of the vertex, and we get the vertex corresponding to that from our vertex list. So now this variable v will contain the 3 floats corresponding to the vertex indexed by this index here. So we update the return array with the data from this vertex, as you can see here. So we're adding 3 floats, and we change the index which we are tracking in the return array by 3, since we filled already 3 floats. And then as you can see here, if we want a texture, we will get the corresponding texture and then add the 2 floats. And if we have a normal, we will get the normal and also append the 3 floats corresponding to that. And that's it basically. After calling this function, we will have our vertex data arranged as we want them for this PCTObject class. Now let me add an object folder here inside our asset folder. And inside this folder, I will add also another subfolder. I will call it cube-like. And inside this folder, I will put the exported obj file from Blender plus the texture. So you can see here we have the obj file, and this is the texture we were using. And now let's go to the main activity and add the code to load this obj file. So we need a wavefront loader. Let's call it WV loader, and it requires a context and the path of the object. We'll give it the path to our object file. So this constructor could throw an exception. So let's surround it with a try catch, and for now, we will only print the stack trace. And let me define a PCTObject, which will be used to draw the loaded obj file. So let's call it cube-like, and let's put it to null at the beginning. And here, if the wavefront loader successfully created, then we will initialize our cube-like object with the data from our wavefront loader. So we need get faces, and since we know that this object contain a texture and a normal, I will use both of them. Let us put these two variables to true, and then let's translate this cube so it's not blocked by the sun. Let's put it at 3 on the y-axis, and we can also add an update call, and in this update call, let's rotate this object by 2 degrees on an axis 1, 1, 0. You can see here that we've forgotten to put the has color, so false. And then we have the has texture, we want to put it to true. And then we have the texture, and of course we want to add here another boolean for the normal, and we want to put it to true. And now let's go to this PCTObject and update it. So here we want to add another boolean variable. Let me create a member variable here also. And later we will be changing the shaders of this object. So I also wanted for that to add another component, which is the uniform color. So this current PCTObject can handle a texture or a color per each vertex, but not a uniform color. And I want to add that also for this class. And that's the purpose of this new variable here. So now inside the constructor, we need to initialize our member variable has normal, and then we also need to update the stride based on this has normal, and that's it here for the constructor. Now for the onInit, as you can see, we were using this shader called color texture. I will create a new shader from that. I will call it all shader, and we will go through it in a minute. So for now, let us continue here. So we have the creating of the vertex buffer, then loading the vertices, and using the program. All this will not be changed, and then also defining the position, color, and texture attribute. This will also all stay as it is. However, here in the texture, as you can see, we were having this current offset, and we did not update it here because there was nothing after it. So now let's update it with the float per texture, because now we will be adding another branch here if this variable has normal is true, then we want to also define the attribute for the normal, and that's why we need this current offset. Of course, this one here is now not used, but I will keep it anyway. And then that's all for the init function. Now we will not change the update and destroy function. In the draw function, since we want to use the normal, we should add the light variables. So we did that in our sphere object, as you can see here, where we defined light positions and other stuff, and light and material variables. So we will do the same here now, and we also need to add a has normal variable here, similar to what we have before. So we have has color, has texture. Now we want has normal, and of course also has uniform color, since we added also this uniform color. Then after defining this model and view and projection matrices, we will add the definition of the light and material variables. And of course, if we are using a uniform color, we want also to set that uniform color here. And that's it for this draw function. What's left now, however, is to create the shaders. So let's go to the color texture shader, and let me copy and paste it and call it all shader. Same for the fragment shader. So in the vertex shader, we have this a position, a color, and a texture, which defines our attributes. And now we have another attribute called it a normal in the Java program here. So we need to also to call it a normal inside our shader. Then we have our output color and output texture and the flags. So if we have a color or a texture, let me add to them also has normal. And for using the normal, we also need another two output variables. One is the fragment position and one is the normal. Then as you can see here, we have our uniforms, which are has color, has texture, and we added 3 uniforms in our program, and these uniforms are has normal, has color, and U color. So if you remember here in the Java, we were setting this has color, has texture, has normal, and has uniform. And of course, if it is has a uniform color, we will need to set this U color. And that's it. So now these are all the variables which we need to communicate with the Java program and with the fragment shader. So let's go through the code of this shader. As you can see here, we are setting the out has color and out has texture to the uniforms. We will do the same for the normal. Then I will give our out color here a default value, which is white, as you can see. And then I will check if we have a uniform color. So that means this integer here will be larger than 0. Then I will multiply our output variable with the U color, so with the uniform color which we get from the Java. And then we have here if we has a color, so this would be the color coming from the attribute. Then actually I will overwrite the color here with the color coming from the attribute. What we can do also, if you want, you can multiply them. So then you can even have an attribute and modify it by a uniform color here. Let me keep it like this. And then as you can see here, if we have a texture, we will put the output texture to the X and Y coordinate from the texture attribute. And now if we have a norm, we need to do the same as we did here in our sphere. So if you remember here in this sphere, so we were computing the position in the world coordinate and then computing also the output normal in the world coordinate using this transform. So let's do that. Let me copy those lines and put them here. You can see now in the sphere, we were computing the normal from the position by just normalizing the position. However, here we have an attribute called a normal, as you can see here, and we will get the normal from this attribute. So this line, actually, we don't need it. Here we directly get the normal, and then we'll transform it to the world coordinate. And that's it for our vertex shader. Let's go to the fragment shader. So the fragment shader, we will also need to change it similar to what we did here for the sphere. So we need to define the materials, the light, and then do this computation. And of course, now we added also a uniform color and other stuff. So let's handle all this now. As you can see now, we have these two input variables, which we get from the vertex shader called out color and out texture. So here we need to also add the out normal and out fragment position, which we need for the lighting. Then we have these flags for having a color or a texture. We also need to add a normal for that. And then we have our output from this class, which is the fragment color. And we also have our sampler for the texture. Those we will keep them as they are. Then we need to define our material and light. So these are the structure of the material and light. And then we need 3 uniforms, one for the camera position, and one for the material and one for the light. These three uniforms which we are filling here. And now here we start by initializing our output color, so-called fragment color, to all ones, and then we look if it has a color, we modify it by the corresponding color. If it has a texture, then we also modify it with the corresponding texture, and then we are putting this fragment color to be the computed color and one for the alpha component. This we will leave it as it is, and now we will check if we have a normal, and that means this variable should be larger than 0. Then if this is happen, we need to add the lighting. So this is a copy paste from our fragment shader here. Let's go quickly through the code. So the first computation is the ambient component, then the diffuse component, then the specular component, and then we compute the final result by just adding these three components, and then we convert it to a vector of 4 and also adding 1 to the alpha component and then multiply it by the fragment color, and that's it for this shader. Now we can go back to our activity and check. So apparently we still have error. Let me run. So now we have changed our PCTObject and we did not change our current code here. So we need to add a variable here, a boolean for the normal, and let's put it to false since the sun does not have normal data. And I also forgot to refactor this variable, so let me refactor it, and I will call it so position, color, texture, and then add in here for normal. Now let's run. So we have a problem. Let me start debugging. Let's look inside this cube loader. So it seems that here we have the vertices. Everything is okay. However, here in the shader, we have compiling error and it says Boolean expression expected. So let us go to the shaders, and you can see here we have our fragment shader in the wrong folder. Let me move it here first. Now let's run again. So we still have an error. So I assume here we need a Boolean expression. So this should be larger than 0. And let's rerun. So it's working, but we don't see our object. So let's go to the activity and check what's happening. Yeah, so we forgot to add the object to the scene. So we'll add the cube-like object. And let's rerun. So you can see now our object here in the top of the scene. And you can see also that the lighting is working. So the side facing the sun has more lights, and you can also notice this specular light. And that's it for this tutorial. I hope you like it. Please give it a thumb up and subscribe to the channel. And I hope to see you in the next video. Bye.